Hey everybody, it's Mr. Carr again. Today we're going to be looking at our absolute value functions and transformations of those graphs. So we have done our absolute value equations, but now we're going to look at just very specifically the graph of these. Okay. So when we look at this, we're going to start with graphing what's called whoops, the parent, come on. We're going to graph the parent function of the absolute value function. That is y equals the absolute value of x. Okay. So when I look at this, y equals the absolute value of x, we're going to plot a point at 0, 0. Okay, that's my standard point right there because the absolute value of 0 is 0. Every point that's on the graph has a symmetrical point like this. So for example, if I go to positive 1, absolute value of 1 is 1. That's this point right here. Same thing if I go x is negative 1. Absolute value of that is also a positive 1. Okay. Okay. So then that means that these patterns are going to go on forever like this and like this. Okay. Nope, should have made that a little longer. Whatever, it's fine. We get this V shape. And at the bottom of that V shape is a vertex. That's that absolute value of 0 equals 0. There is no matching pair on the other side. We can modify this parent function by using this format. So that's what we're going to look at today. What happens when we change these values of A, H, and K? Okay. So first, we can add or subtract a number outside of the absolute value. That's our K number. Okay. So we can take a brief look and see what that does. In fact, yeah, I'm going to just go ahead and do this all real quick. Let me go to Desmos real fast. Okay, and here we are set up on this. So when you look at this, you can see A, H, and K. I've got sliders that represent this. When that K value, if I add a positive value on the front, like if I make it a positive 1 or 2, you see what's happening. It's shifting it up. If I make that a negative value, the K on the outside, it takes the whole thing and shifts it down. Okay. Whoops. Jump right up there. So let's come back to 0 for a second here. Oops. There we go. Okay. Okay, we'll just do this. 0. Okay. When I do H now, keep in mind, H is the value that's inside right there. So when I change H, if I move it to make it a positive, that's X minus, for example, X minus 3. Well, X minus 3 moves it to the right. If I go in the other direction, like X minus 2, like if I go here to a negative 3 here, that's moving it to the left. But when I look inside the absolute value sign, that is X minus a negative 3. So it turns into a positive 3. So we'll see that when we do a little bit more by hand. But the idea is that we can show our transformations going left and right based on that H value. Okay. Oh, let's get you back in that spot. There we go. Now for A. A has two jobs. If I make this a larger number, you can see that it is getting skinnier. This is called a vertical stretch. We're stretching it this way. So that's what creates that image. Whoops. Come back here. Okay. We're stretching it really thin like that. If I take that 1 and I go to a decimal number that's a little less than 1, like this, you can see that's getting wider. So when it does this, it's actually doing a vertical compression. It's pressing down and making it flatter is the idea. And the big one is, let's see what happens when we make it a negative. We reflect it. So it doesn't matter which way it is. If it's negative, it can do two things. It can do a negative with a reflection. Sorry, it can do a stretch with a reflection. It can do a compression with a reflection, or it can just do a reflection if A is a negative 1. Okay. So we can see all these different things. So we can do a combination of things. We can have a vertical stretch. We can have a horizontal translation. Come on now. Horizontal translation to the right and a vertical translation down. We can do all of those things. So any combination there for our transformations of these graphs. So let's come back. Whoops. Come back here. Try that again. So we come back here so we can see what the K does. It moves it, does a vertical translation. That's the job of K. It moves it up and down. That is a vertical translation. When we add or subtract a number inside, this is the H value. This is going to be a horizontal translation. All right, sorry, I already answered that, but these shifts or slides are called a translation. Any kind of physical movement, up, down, left, right, that is a translation. So has this graph been translated? So you see the x minus 4, the plus 1 like that. This is going to go, and when I do a horizontal, it's going to go opposite the number. Okay, I'm going to come back here too. When we have the k, we get a vertical translation and it goes with the number. Okay, it's going to go the same direction as k, going to go opposite that, whatever h is inside. So what I mean by that is this, I would expect, is going to go 4 units to the right. With it being a -4 inside, it's going to go opposite. It's going to go 4 units right. This tells me it's going to go 1 unit up. Okay, so we got 4 units to the right, 1 unit up. Our vertex should follow that same pattern. Remember the parent function, when I come up here, the parent function is at the point 0, 0. So if I'm going to move to the right 4 and up 1, that means my new vertex should be at the point 4, 1. So let's confirm that real quick with Desmos. If I come back, let's just go, let's see here. Can we reset everything? That a 1, whoops. Make that a 1. That's going to be a 0, and that's going to be a 0. Okay, so the absolute value of x minus 4 and then plus 1. You can see from here, my vertex is at the origin 0, 0. My other vertex is at 4, 1. It shifts to the right and it shifts up. So we do confirm that's what we have here. So lastly, the change in the number in front of you, you're multiplying by the a value. As you saw, it does 2 things. We can get a vertical stretch, and that is when a is greater than 1. And I should say this, I should say the absolute value of a, because we'll get to the negative ID again. Or it gets a vertical compression. Okay, and that's when the absolute value of a is in between 0 and 1. So if a is in between, the absolute value of a is in between 0 and 1, we get a vertical compression. What happens if the a value is negative? We get a reflection. And more specifically, it's a reflection over the x-axis. Okay, so when a is negative, all right, we answer that. When a is negative, the graph is reflected over the x-axis. All right, so when I look at something like this to sum up, the equation of an absolute value, or sorry, the equation of an absolute value equation is given by this: a times the absolute value of x minus h plus k. Our vertex is always going to be the point hk. And again, notice that it is the opposite of what's inside the absolute value, but the same as the number on the outside. If we get the absolute value of a is greater than 1, it's a vertical stretch. If the absolute value of a equals 1, that is our normal or parent function. Okay, so it's our normal parent function at that point. If the absolute value is in between 0 and 1, we get our vertical compression. And if a is less than 0, we reflect, specifically over the x-axis. Okay, and then h causes a horizontal shift. And it goes the opposite direction of what's inside. Okay, k is a vertical shift. And it goes the same direction as whatever the number is. Okay, so compare the graph to a parent function, describe the transformations, find the vertex, and does the graph open up or down? So when I look at this for all my steps, I have 3, 1, and -2. So when I do this, I'm going to set it up as, well, let me find the vertex first, because the vertex is based on these 2 numbers, which is -1, -2 in this case. So my normal parent function starts at 0, 0. I'm going to go -1, -2 for the new one. Okay, does the graph open up or down? Because this is a +3, I know the shape is going to look like this as a V. So it opens up. So we're going to graph it using our slope. Sorry, the slope is going to be related to the stretch in the front. Okay, so we're going to graph using our slope in here in just a second. So sorry about that. Yeah, so this stretch is going to be, we're basically going to treat it like it's a slope then. So if I describe all my transformations, like just very informally, we're going to go to the left one, where you're going to stretch by a factor of 3, and we're going to go down 2. Okay, so that's my informal way of doing it. So we can see where the vertex is right here. With my stretch of 3, that means I can kind of treat it as a slope of 3/1 and -3/1, meaning it's going to go from the vertex, it's going to go 1, 2, 3 up, 1 to the right, 1, 2, 3 up, 1 to the left. And go 1, 2, 3, and 1, 1, 2, 3, and 1. Do the same thing like that. So there is my absolute value. That's the transform version there. Okay, so let's do one more example. We got -1/2 times the absolute value of x minus 3 plus 2. So we'll look at all of our transformations. So we're going to go from here, we're going to go to the right 3. Here we have 1/2, so we have a vertical compression. It's negative, so we're going to reflect over the x-axis. And finally, we're going to go up 2. So if I look at the origin as my starting point, I'm going to go 1, 2, 3 to the right. No other changes for the vertex, but I am going to go up 2 right there. So there's the graph vertex. So we're going to have, sorry, the vertex is going to be at the point 3, 2 here. The graph open up or down, it's going to be down thanks to our a being a negative 1/2. So it's the negative number that makes it go down, so or opens down. And once again, we're going to graph using our slope idea. So in this case, my slope is a -1/2. So I'm going to do it this way because I know it opens down. I want to go down for my shape. So I'm going to go down 1 to the right 2. I'm also going to go down 1 and then to the left 2. So from here, I go 1 to the right, 1 to the left 2, and same thing a couple more times. And there's my absolute value. All right. So again, that's how we get our transform graph. Find that vertex, apply this stretch / compression for as a slope. So don't forget, you can also graph these in your TI-84s if you wanted to, not just Desmos. So it was a little bit easier. So if you're looking to enter those, you're going to use your math, go to the number, and option 1 is the absolute value part. So you can always go to Y1 and do the graph and type it in just like this. Okay. But that's it for today. So again, we looked at what effects we can make on our parent function for an absolute value. We get this V shape because of the symmetry with our how absolute value is defined, but we can move it around and we can see all these different things when we go through that. All right. That's it for today. Take care, everyone.